Good evening. At least good evening for me. This is live training from Unity Technologies, and tonight's session is on UI, panes, panels, and windows. My name is Adam Buckner, one of the live trainers here at Unity Technologies. And by the end of today's session, we are going to be able to create a panel. We're going to be able to move it around on the screen. We'll be able to open and close it. We'll be able to resize it, and we'll be able to focus it to the front. Now, I'll admit that I may have been a little over-enthusiastic when I made the entry for today's session, because I threw in a bunch of other things that I was hoping to get to, like scroll bars and other things, but I'm not sure I'm going to get to them tonight, because when I sort of timed this out, I don't think we're going to get all the way through. So let's go ahead and get started. So I've got here a new empty project, well, relatively empty project here in Unity. I'm using 4.6 because we're using the UI today, so 4.6 beta. And what I'm using this as a base, just to make it look pretty, I'm using Nightmares. We can get Nightmares from the Asset Store, that is Window, Asset Store, or Command 9, and then we can search for Nightmares as part of the Unity Technologies offerings, the stuff that we've put up. So yes, we're looking for Nightmares, and so that's where our Nightmares has come from. And so that's the Nightmares project, and you can import that. But again, I'm just going to be using that for a backdrop. So let's go ahead and open up a scene. I'm just taking the finished level 1, and I'm going to then do a save as, and I'm going to save this at the root level of my assets as just a demo scene for tonight. So there's our demo scene, and I'm going to close that down. We've got a bunch of things in here we don't need, so I'm going to create a new empty game object, and let's just call this disabled. And I'm going to throw a bunch of stuff into here. Let's go ahead and grab the enemy manager, the player, our spawn points, our canvas, the current existing canvas, and let's get rid of the background music, because this is all stuff that we don't need. And then go back to that root and deactivate it. So I've just sort of thrown all of those essentially into the trash, but I don't want to delete anything in case there's some dependencies going on. So anyway, so we're set up. There's our base place to get started. And again, because we're looking down here at the game view, I'm going to grab my camera. And again, purely aesthetics, it's nothing to really do with tonight. I'm just going to double the viewport so it's not so tight. Give us something interesting in the background. So we're going to be making a UI panel. And to do that, we're going to be doing this in screen overlaid mode. I'm going to be laying the UI panel on top of my game, and in which case we're going to be working in 2D. So let's go ahead and take our scene view and push it into 2D mode, and that's with the little 2D button up there. I'm going to start off by creating a UI panel. So let's go ahead and just come over to the hierarchy and hit Create UI Panel. And then let's focus in on that panel. And remember, our canvases are much larger than our game. And I'm not going to go into the details of that. We've covered that in other lessons about the canvas, and it's also, we can find that on the Learn site. So this is our panel. One of the things I'd like to note about the panel is that the panel, let's also take a look at the construction of the panel versus image. The Rect transform here, a canvas renderer, and an image. If we were to create a UI image, we would see that the setup is primarily the same. It's just got some slightly different setups with the way that the default image works, but it also has that Rect transform, the canvas renderer, and the image script. So some people have asked, why do we have both the panel and an image? Well, they're pretty much the same, except the panel is stretched out and the image isn't. It just gives you a slight edge up on getting started. So let's get rid of that image and go back to the panel. So currently, when we've created our panel is going to fill the canvas, because that's one of the default settings for the panel. I don't want my panel to fill the entire screen. So I mean, I could go ahead and grab it and move it using the Rect tool. But now I've left my anchors back along the edges. So let me undo that. I could grab the anchors. Whoops, oh, I rotated it. So let's come on, grab the anchor. Grab the anchor. Now I've moved the anchor, but not the background. Well, there is a little trick that we can have here. And that is if we hold down the Shift key, which honestly I'm doing, and then you grab and not rotate. See, there's the little rotate symbol going on with my cursor, but you just grab the anchor. You can move the corner and the anchor at the same time, which is convenient. So we've sort of grabbed our panel, we've kind of pushed it up into the corner, some random size, nothing specific tonight. let's go ahead and take a look at what happens when we have our anchors set like this. And when you've selected a UI element, you can always test the parent. And you can see the little preview there by sort of grabbing the parent. Now, normally you can't resize the actual canvas, but this gives us an idea. If I was trying to resize the canvas, you'll find that its Rect transform is locked and I can't resize it. But when I have the panel attached, it'll show me what would happen if that resized or if we changed our resolution. And we can see that our panel is stretching because of the way that our anchors are set up. I don't want the panel to stretch. I want it to be a solid window. Later I'll talk about how to resize it. So I want to have all of the anchors in one point. I want to anchor my panel at one position. So I can go up to the anchor presets and let's anchor it into the upper left-hand corner. And now I also want to set the pivot. So hold down the Shift key and set the position, which is already there. So hold down the Alt key and then click on that. And we can see that the anchors have now gone up. If we were in, let me undo that. If we were in another position and I hold down both the Shift and Alt key, when I'm repositioning it, you'll see that it snaps up there into the corner. Let's give it a little bit of distance. Let's give it, is that a good shape for our panel? A little bit more narrow, why not? And let's bring it down off the edge a little bit. So let's give it a little bit of space. 24 by 24, looks good. Just a little bit of space so that panel isn't crammed up in the corner. So we've got this UI, let's add some UI panel artwork to it. So I've got some demo texture sprites, which we will link. I'm going to try to get these incorporated into the 2D pack, which is also available up on the asset store. So maybe by the time you're watching this, if you're watching it in the archives, you'll see that these are part of the 2D pack, and definitely we will have a link to that in the archive page. So let's look for panel, and we've got UI panel. Let's go ahead and drag that UI panel into the image. Click on panel, make it the background, UI panel, there we go. Bah. So there's our UI panel. It is a simple sprite at this point, and what I really want to do is have it to be a sliced sprite, but this image doesn't have a border, so I quickly want to take a look at how we would slice up a sprite. So let's go ahead and take a look at our UI panel element, and we can see it set as a single sprite, and I want this to be a sliced sprite. So the first thing I want to do is change that to multiple, because it's going to allow me to trim my sprite even more tightly than it is as a single sprite. And we apply that, and then let's open that up in the Sprite Editor. Now the Sprite Editor, I've docked the Sprite Editor here. If it's not docked, the Sprite Editor will open when you click on it, and then you can go ahead and dock that Sprite Editor. I want to go ahead and slice this up, so I'm going to use the automatic slice, the automatic slicing tool. I'm just going to leave this automatic. So automatic slicing, the pivot's in the center. I'm going to delete any existing slices and go ahead and just chop that up. And we can see now, if we look at the single sprite it's made, it's been completely trimmed. I also want to get rid of the shadow that's here at the bottom. It just happens to be that the artwork has a little bit of a shadow, which normally would look nice and fine, but let's go ahead and just trim that out because I'd like this to be perfectly even. And then let's go ahead and grab our slice tool and slice this in just a little bit. How much do we want to go in? 15? Let's just do 15. We can also set these by hand. A good slice there on the edge. So there we go. We've sliced it. And when we've sliced our background image, what it means is that the corners don't stretch at all, and the edges only stretch on one axis, so that our edges stay nice and clean and our corners stay crisp. So let's go ahead and apply this. So we've now applied that change. And we can see that we now have a nice crisp panel, nice good corners on our background. There's also one other thing I'd like to show you here. If we look at our panel, there is fill center. And if we turn that off, we can see the center is not being filled. So anything that's inside the center of the panel is not being drawn. So you just have the border region creating a border. And I'm going to leave that in for aesthetic purposes. We aren't going to put any content into this panel today because I don't think we're going to have time. So there's our very basic panel. I want to create a label to go on top so I can identify what this panel is. And with that perfect border all the way along the edge, I don't really have a lot of room at the top. So again, let's go back to our artwork. Let's go back to our, just click it this way. We go back to our UI panel. And then let's look it up in the Sprite Editor again. And then let's pull down our top cut, our top slice. Let's pull it down enough to give us a little bit of space. I don't know, 45 looks good. So then this whole section at the top is now not going to stretch. So I'll have room to put in a label. So let's go ahead and apply that. And you can see we now have room for a label on top of our window. And that area won't stretch because it's inside that 9 slice. So to create a title, we've created a title space. Now let's create a title in that. And so we need to create a text item. And so we don't put that on the canvas. We put it on the panel. And let's go back to our scene. We put it on the panel. So when we've selected the panel, we can create a new UI text item. And when we're using the context menu, if we have an item selected and we create an item, it should come in as the child. So there we go. The text is a child. If we had the panel selected and we did the create from the hierarchy menu, we can see that that text is just thrown onto the root of the canvas. So that context menu is really useful if you want to place things specifically in a level on the hierarchy. And don't forget, the order in the hierarchy is what describes the order at which the items are rendered. The highest things in the hierarchy are rendered first, and the ones at the end of the hierarchy are rendered on top as the last item. So we have our text item. Let's call this title. And if we look at where it is, it's stuck in the middle of our panel. We've got that text is sitting here in the middle of the panel. And again, I want this at the top, and I want it stretched from side to side. So we can go to our anchor presets, and I can pick align top and centered. And again, if you hold down the Shift key and the Alt key, it'll pop up. Not only will it set the anchors, it'll also set the position. So let's go ahead and drag that label down the bottom just a little bit more so it fills that label space. Now let's quickly change our type. So we're going to change our text, which right now is just a simple Arial font. So let's call this panel. How about panel? What should we call this? Panel. And let's change this to Luckiest Guy because we have it around. Luckiest Guy. It's the font that comes with Nightmares. And then we will center that. Make it bigger. I think about 30 would be about fine. And then let's change its color to something complementary to the scene. Probably a cyany blue type color would be cool. So now we have a label. If we don't like the positioning exactly, we can adjust it with our pause Y, with our position Y, so we can center that up if we felt that it was better. -5, make that an even number. So that there we've got our panel name. Metalcat is asking, is there a way to order the hierarchy alphabetically? I want to sort created items and recognize the odds of them. Yes, you can. Look in the documentation and you will find a sort by alphabet script. So now we've got our panel. Let's go ahead and get it dragging. So let's create a scripts folder. Let's close this down. And let's create a new folder. And let's call this folder scripts. Place to hold our scripts. And let's create a new C# script. And let's call it drag panel. And then let's go ahead and open this up in MonoDevelop. To write some of these scripts, to write these UI scripts, we need a couple of new namespaces. To start off with, we need to be using Unity Engine.ui. So that has all of the terms for our UI namespace. But we also need to be using Unity Engine, learn how to spell using Unity Engine event systems. Because what we're going to be doing is implementing some interfaces here. And for that, we need to inherit from iPointerDown handler and iDrag handler. So if we go up to the top of our class, we've got our public class named dragPanel, and we're inheriting from monoBehavior, but we're also going to inherit from iPointer, and we want down handler for this one because we're interested in the pointer coming down, and iDrag handler. So what we want to do with this script is look at our pointer, where it comes down on the panel, and then look at the change in position of that pointer and apply that to a change in position on the panel itself. So some of the things that we need when we're getting started, and as a matter of fact, we don't need any of this stuff, is we're going to need a private vector2 because we're dealing with 2D space, and this is our pointer offset. And then we're also going to need a private Rect transform. And this rect transform is going to be the canvas rect transform, because we need to have information about the canvas, and then we also need a private rect transform, and this is going to be the panel rect transform. So some references to the canvas, references to the panel itself, and then a variable to hold our pointer offset. So in awake, when we wake up this script, we're going to grab some of these references. First one is our canvas. And so let's just call it canvas. And it's going to be equal to something called getComponent in parent. Actually, we want the singular. Component singular in parent. GetComponent in parent. And the component we want is the canvas. We should be aware of how getComponent in parent works. There you go. I'm going to reduce this in a second when this, because the script is going to be too big at this size. Actually, let's bring it down a little. Hopefully that's big enough. GetComponent in parent is a bit deceptive because it will also look in the current game object. So if you're looking specifically for a component that you know is in the parent, and you have a duplicate component in this game object, you may get confused. So you'll need to find the parent first and then get the component. Whereas what this is doing is starting with this game object and looking all the way up the hierarchy until it finds the first instance of canvas. The convenience of this is we know there's no canvas on our panel, and its root parent is going to have that canvas that we're grabbing a hold of. So just out of curiosity, we want to say if our canvas is not equal to null, if our canvas is not equal to null, and this is just an insurance check so that we don't get a null ref somewhere that causes some problems, we want to take our canvas rect transform and say that's going to be equal to our canvas dot transform. And as rect transform. So we're just finding that that transform, which we can do with a little dot transform, will find us the transform, and we want to cast it as our rect transform. And then we want our panel rect transform to be equal to the transform, again as rect transform. So that's grabbing our references. Then when the pointer comes down, we want to do two things. We want to grab our pointer offset, but we also want to focus the panel. Because remember, when we're looking at our items, there's only going to be one panel here, but if there were multiple panels, let me show this off, our multiple UI elements. Let me show this off by making an image, just a random white image here, and let's put this up in front of our panel. So our panel is buried now behind another UI element, and we can see that in the canvas. The panel is first, the image is second. So what we want to do when that pointer comes down in public, now this has to be a public function, public void on pointer down. And then we need to get the event data here. And the event data is going to be our pointer event data, and let's just call this data. We get our pointer down, and so the first thing we want to do is take our panel rect transform, and we want to do set as last sibling. So we want to grab this and set it to the front. So it's going to put it to the last sibling on the canvas, so it becomes the object that is rendered last, so it becomes the object on top. And then we want to take our rect transform and find the offset of where our pointer comes down. And there's a thing called rect transform utility. I'm not going to look that up in the documentation today because we're going to be gunning to get done on time. But definitely rect transform utility has a bunch of, believe it or not, rect transform utilities. So let's go ahead and take a look at that. And what we want to grab out of that is, screen point. So we can do screen points on our rect transform utility, and we want to take the screen point to the local point in rectangle. So we're asking this particular function to find out where our pointer came down and where it came down on the panel. So when we're looking at it, where did it come down on the panel so I can get my offset locally on that panel? And this is a bit long and complicated. You can see that there's a bunch of different arguments that we've got to send in. So the first one we want is the Rect transform itself. So we can give it our panel Rect transform. So that's the Rect that we're looking for. And then where is our screen point? It is the data.position. So it is the position of our mouse. So the rectangle that we're looking for is the panel. The position is our mouse. And then we want the camera we're taking it from is the data press event camera. Press event camera. There we go. The data press event camera. And then we want to save as an out. So it's going to be setting this our pointer offset. So this will give us our pointer. Oh, I don't like it when nothing completes. Oh, let me just copy and paste that. So it always worries me when MonoDevelop stops completing, because then it tells me I've done something wrong. But that looks correct. You worry me, MonoDevelop. We'll find out in a second. So that should be that line, nice and long. Only one of those. So so we've grabbed our offset using the Rect transform screen point to local point and rectangle function. There's a mouthful for you. And so that has set us to the last sibling and has gotten our offset. So then we want to drag it around. So public void on drag. And again, we're taking our pointer event data, which we'll call data. And we want to say if our panel Rect transform is not null, if our panel, let's do it this way. If our panel Rect transform is null, we will return. We'll just say, bail out of this, go back to Unity. And then we want to take our vector 2, which is our local, which we're going to call our local pointer position. So there's our local pointer position, vector 2. And this will be set by the next thing we're going to say is this is our if, our Rect transform utility again. If our Rect transform utility, these are really nice and short, aren't they? To local point and rectangle. And so if we get our Rect transform utility screen point to local point and rectangle, then and we get that with our canvas Rect transform because we're looking at the canvas. So we have our canvas Rect transform, our data.position, our data press event camera, again, that's the camera we're taking it from, and then we're getting out of that our local pointer position. Oh, I've done that twice, so let's refactor that. Local pointer position, local pointer position. Yeah. So we're running out of space. So let me just quickly change this around. I'm going to tab this down. So this should make sense. So if we have that, then we want our panel Rect transform dot local position is going to be equal to the local pointer position minus the pointer offset. And I'm sure we're going to find some mistake in here somewhere. Close our brackets. So let's save this and figure out what we've done wrong, and I'll walk you through it. If this compiles, it's gonna be a miracle. Whoa! Look at that! I can't believe I got that without any errors. Okay, so in a wake, we're grabbing our canvas and our panel. We are setting last sibling, and then we are going ahead and grabbing our offset, and then in the drag, if we have a panel, we've got our local pointer position, and then we compare that and we set the offset. So let's save this. Let's go ahead and play. Make sure there's no. Oh wait, let's put it on the panel. I'm so enthusiastic about this that I've done it. I don't have the script on there. So let's go ahead and put the drag panel on that panel. Let's save. Let's play. And hopefully this will drag around. Look at that. That drags around just fine. And you can see that we've popped in front of, when we touch it, we pop in front of the image. So we come to the front. And we're at the front of the image. Now, one of the things that's a problem with this particular code is I can drag anywhere on the panel and I can move the panel. And sometimes this isn't desirable because if you've got content, you don't want to be moving the panel around. You want to be moving your content around. And the solution to that is to actually put in a hotspot up at the top around where the panel title is and have the panel only draggable by the title, or you can duplicate hotspots around the around your panel. So there's a couple of modifications that we need to do to be able to get a little hotspot for our drag panel. And don't forget, I will paste this code into the archive so that you can go ahead and grab it rather than having to copy it off of this. Speaking of which, there is a known flaw, which is this camera has an empty script on it. So that's just getting rid of that for that mention. So we need a hotspot. So let's remove this script from our panel. Let's take the drag panel off because we're going to put that onto the hotspot. Let's add an image to the panel. And again, click on the panel and then use the right click to get our image. And I'm going to remove or move this image out of the way. This other one, you are bugging me. Go away. So we now have an image. And we're going to use this image as our hotspot. Let's go ahead and set its anchor. No, wrong one. That one. The image. Let's just call this, and let's call this drag zone. So that's our drag zone. And then let's change that also to the top. And then we can adjust its size to what we need it to be by sort of dragging it around. It should snap internally to the bottom of that slice. We can make the image none if we want to, which it already is, but we will have to change the alpha of this to 0 because we don't want it in the way. We can't turn off the image script because we're looking at the image script itself to be the hotspot. So since we don't want to see it, we've got no source image, and our color can be anything, but our alpha needs to be 0 because that component needs to work. That's our drag zone. We do need to make a change to the code though, because when we add our drag panel onto this, we will now simply be dragging around the hotspot rather than dragging around the panel itself. And so let's come back to our code. And what we want to do with our code is add in a parent level. So we don't have to change what our panel rect transform is, but when we're grabbing the panel rect transform, it's not the transform of the object, but in this case, it's going to be the transform.parent. So it's going to be the transform of the parent as a rect transform. No, that should work. So let's just try that. Because I've got one more change I want to make to this panel. I'm looking at the same code. So now we're dragging the hotspot. We drag the hotspot, and we can't drag the rest of the panel. So the only difference we needed to make with that code for the parent is how we grab our panel rect transform. So instead of transform as rect transform, it's transform.parent, which is a transform, as the rect transform. But the other problem we have is we can now drag this panel off the screen. And when we drag it off the screen, we can no longer get a mouse down to get it back on again. Let's constrain our mouse position. So the easiest way to do this is that, you can do some slightly more complicated code to try to clamp the panel itself, but let's clamp our mouse position so our mouse position doesn't go off the edge of the canvas. So coming back to our code, we want to clamp this. So what we would need to do at the beginning of our drag is say we want a vector 2, and this is going to be, well, let's give it some space here, our pointer position. And our pointer position is going to be equal to a function we're going to write called clamp to window. And we are going to send the data that we get from our pointer event data. And then we're going to change instead of taking raw data position here, we're going to take our returned new pointer position. And then let's go ahead and write this new function. And it does. It can be private, so it's just a void clamp to window, and it takes in our pointer event data, and we'll call that data again. And what do we want to do here? We want to grab a vector 2, excuse me. That's going to be our raw pointer position, and that's going to be equal to our data dot position. So that's the data position, the position of our pointer that comes in from the data. And then we need to get the corners of our canvas. We need to know where our canvas is. So when we look at our canvas, I want to know where these 4 corners are. And there's a convenient utility. So we can make, and these are vector 3s because those corners are in 3D space, but also this is a collection. It's an array of vector 3s called canvas corners. Canvas corners. And they're going to be, let's set that to a new vector 3, and let's give it the size of 4. And we have our canvas, we want to take our canvas rect transform, and that needs to be .get world corners. Get type, crackers. Get world corners. Thank you. And the world corners that we want to get will go into canvas corners. Now this is it seems a bit backwards, but we send it canvas corners into get world corners, and it will, similar to out, go ahead and populate that array with the corners that we need. So that gives us the 4 corners on our array. And then what we want to do is create 2 floats to clamp our mouse position. Clamped X and clamped Y with an L. Clamped X. And that is going to equal to mathf clamp. We know all mathf clamp, don't we? And it needs to be our raw pointer position, .x, because that's what we're clamping. And it's going to, when we're going to clamp it to the X and Y on 2 corners, what we can do, and there's various ways that we can look at we want to clamp it to the X and we want to clamp it to the Y. There are several ways we can skin this digital cat. My choice was to take corner 0, which is the lower left, and corner 2, because they go clockwise, 1, 2, 3, and 4. So to count lower left and upper right, and look at the X and Y values to that and clamp them. So my raw pointer position X is going to be clamped from my canvas corners and canvas corners 0 .x, and my canvas corners 2 .y. Oh, sorry, .x. I lied. .x. And then for the Y, same thing, do a float clamped Y. And then we're taking a raw position Y, our canvas corners Y, and our canvas corners Y. So I'm taking the X and Y from both of those 2 corners, and so I'm getting my X and Y values. Then with those, I can then say I've got a vector 2, and it's the new pointer position, and it's going to be equal to a new vector 2 made of clammed, no P, I'll have to fix that, clammed X, clammed X, good God, and clammed Y. We can make dip out of it. Let's add some P's. Clamped. And then, of course, lastly, we will return that new pointer position. So what we're doing with this is that we're looking at the pointer position. It comes in, and we clamp it immediately, and then with this function, and then we only position the we only positioned the panel on the screen using the clamped position. So let's save this. Let's go ahead and, oh no, what have I done? Oh, void. This is a vector too. Let's get my return types correct. So yes, what else have I done wrong? Mathf clamp. Crackers, I'm Russian today. Yep. There we go. So, we had one miracle and one disaster. There we go. On coding side, let's save that. Let's go ahead and hit play. And we can see now that we can drag the panel and then we stop on that mouse position. I mean, we could, if we want to be incredibly annoying, try to get it right down to the edge and leave only a fraction of a sliver to pick it up. But we've now clamped that panel so that there isn't really a technical way we can get it completely off screen, even if we could get it small enough. Let's go ahead and find a way to open and close this panel with a close button. So again, grab our panel and using the right click, let's go ahead and add a new UI button. And let's go ahead and call this one Close Button. The Close button doesn't look that great, so let's go ahead and look at our art choices. So let's go ahead and grab the UI toggle button and use that for our art. And shape's pretty kind of ugly there. There's a neat little utility we have when we're using a simple sprite. It's called Set Native Size. If you click on that, it's going to make the button the native size of the original artwork. And this original artwork was 32 by 32, so we have a nice round button now. So now let's go ahead and change the text. And we can use that to get our lovely X. Let's change button to X. And again, let's grab luckiest guy. It's becoming the luckiest font. And change this to our wonderful color. I think that was 200 by 200. So giving us a cyan. And make it a bit bigger. 24 maybe. That looks good. And it's not aligned perfectly, even though it's centered. Part of that has to do with how much space the font is giving itself. I don't know what it looks like. About 6 looks good. It looks a little bit to the right. You know, we could be picky. Give it -1. And again, setting that, no, not the text, the button. Let's set that up to the upper right-hand corner. And we need to give it some breathing room. So let's bring it down a little bit. How about a clean -6? Looks good. And then let's bring it over a little bit as well. Just off that edge a little bit. Maybe -4. So we've got a close button in the corner. I'm sure we could perfect that. Now with these buttons, we now need it to do something. So let's create a C# script, but let's create a generic toggle button, something that'll toggle any panel. So let's create a new C# script in our scripts, and let's call this toggle panel button. Toggle panel button. How's that? And let's open this up in MonoDevelop, and it's going to be a very simple script. It's going to simply say, and remember they need to be public, a public function just called toggle panel, and it should take in a game object, any game object, and let's just call this one panel. And that panel, we're going to simply say, take the panel, and do a set active. But since this is a toggle, we want it to be not the panel's active self. So this is going to look at the panel itself that is being set and say, if it's off, active self, set active to turn it on. If it's on, set active to turn it off. And because we're taking a generic panel into the as the parameter, we can, as an argument, send any game we can send any game object to it and we'll turn it on and off. But let's just pretend and stick to panels at this point. So we can save this back to close this, come back to Unity, and because this is a generic script, let's pretend we're making a large and complex game, And let's create a new empty game object that's going to be our game controller. And on our game controller, we've got our toggle panel. So now we need to get this to work with opening and closing our panel. So let's go back to our close button. And what we do here is we use the on-click event list. You can create a list for many different types of events, but built into the button script is the on-click list. So let's create a new thing to do, a new action to do when the on-click happens. And what we want it to do, we want it to happen all the time, not just at runtime, and we don't want to turn it off. And we want it to do something on the game controller, so the game object goes here. And then we will look at all of the components and their functions in the game object and pick toggle game object. And the game object we want to toggle goes into the parameters list here, and that will be the panel. So we can save that and hit play, and now it closes it. Can't get it back, but it's closed. It's gone. How do we get it back? Well, let's get out of play mode, figure out how to get it back. So let's go ahead and add a new button to our canvas, just a new generic button. Another UI button. And this is going to be our toggle panel button. It'll toggle our panel. Let's go ahead and set that again up into the corner, holding down the Shift and the Alt key. It goes up into the corner there. And then let's back it off. How far did we back off the panel? We backed off the panel 24. So let's match that with our toggle panel button. And then let's just back off 24. So it just looks the same. Same distance we have between the two. And let's make it bigger because we're going to need to have some room for the text. So let's make it 200 by 50. And give it some artwork. There should be a default button here. Let's see if that one, how that works. It looks good to me. And then our text, quick change on the text. Change that to toggle panel. And we'll do that with luckiest guy. And bigger, what's font type size we're using? 24, I believe. And then our wonderful cyan here we got going on. So we've got our toggle panel. Pop that down by a little bit so it's centered. And we just need to repeat the process. This is a brand new button, but we can do the same thing. We can create that empty list, make a new row on our on-click list, and then we can grab the game controller, which holds the script, and then do our toggle panel function. That's the toggle panel function on the toggle panel button. And then we want to toggle the panel. So now what this does when we go into play mode is give us a button that will now toggle on and off that particular panel. And if it goes off, we can bring it back on again. So the beginning of a dashboard or a HUD, you know, you've got all your toolbars down at the bottom and you want to bring up your inventory or your equipment slots or whatever you want. You can make that button work. So resizing the window. Again, we'll need a hotspot. So let's create another button on the panel. So we grab our panel. Let's get out of play mode. So we grab our panel, and then we're going to create, using again that right click, so it'll go where we want it to go, that UI button. And let's go ahead and name this one Resize Zone. So that's our resize zone. And we don't want any text on this one. We're going to do this with just an, we're going to do this with just an image. So let's anchor this into the lower right. So again, we're going to grab our resize zone, and we're going to go to the anchors presets, and then Shift and Alt. Down it goes into the corner. Now, we could animate this button, but there's a little bit of sort of a quick trick we can do to avoid having to go into the Animator today. And I'm going to use an empty image. So it's blank, but it has the same dimensions and the same cuts that I have in the image that I want when I hover or press. So let's go to Sprite Swap, and I'm going to leave that target graphic there. And then for highlighted, I've got my button corner, and for pressed, I've got my button corner. And so what this is going to do is allow me quickly, especially for today's demo, get a hover. And again, it's distorted based on the button size. If we were to set native size is going to be way too big. So now what we're going to need to do is go in here and just adjust this down to something that we want it to be. And let's try 32 by 32, which is just the size that we had for the button up here. So maybe it'll work down for the size down here. So let's save that, go back into play mode. And see, there it is, nice buried into the corner, and only shows up when we go around the corner. So however you want to light up your hotspot, or you can just leave it blank. Often it's incorporated, that corner drag artwork is incorporated into the shape or the color of the texture of the panel itself. When it comes to resizing, it's going to be another long and convoluted script like we had for the dragging. So I'm not going to write this one out, but I'm going to paste it, and then we're going to discuss it. Let's get out of play mode just while I'm here. So let's create a new script. And this script is going to be called Resize Panel. And let's go ahead and open that up in MonoDevelop. There we go. And then let me pop over to my cheat sheet. Oops, didn't mean to have you see that. Let's move that onto the other screen. Resize panel. Copy this. And we're going to paste this whole thing in. And let me walk you through this. This is similar code. Whoops. Trying to make this small enough so you can fit, but still see it. This is going to be similar code to what we wrote for the drag panel, but it's doing the same thing, but looking at the corner. So again, at the head, we're going to need our namespaces. We're going to need to use UnityEngine.ui and our event systems. We are going to extend iPointerDown handler and iDrag handler because we need to get our pointer down and we need to drag. We're going to grab two vector 2s. And that's our minimum size and our maximum size, because you could, in theory, drag the panel down to nothing. But usually you want some point where the panel cannot get any larger or any smaller. So we're grabbing those as two vector 3s. And again, like we did with the drag panel, we're going to grab the Rect transform. And I need to find the difference between my previous pointer position and my current pointer position. So I've got vector 2s for both of those. In my awake function, we go ahead and grab that Rect transform, and we're grabbing the transform of the parent again, because this is a hotspot as a zone on top of the panel. We don't want to move the hotspot, we want to move the parent. So we're getting our transform parent get component as Rect transform, or we could just ask for the transform parent as Rect transform. Now, when our pointer comes down, we're doing the same thing we did before. We're grabbing the Rect transform and we're setting it as the last sibling so that it will pop to focus, become the most focused object, the one on top. And then again, we're using our Rect transform utility and getting that screen point to local point in the rectangle. And this is so we can set our previous pointer position. Because we have to do this each time, because we look at the loop and on drag of what we're going to be doing, we need that initial previous pointer position, even though it's going to be exactly the same thing as the current pointer position, which you'll see in a moment. Coming into on drag, when we've clicked on it, we've set our pointer position, and we drag that corner. So again, if we don't have a Rect transform, we return the control back to Unity. We bail out of our on drag, and we grab the size delta of our Rect transform. And what that is of our Rect transform, that's how big we are. That's our size, our width and our height. So with the Rect transform utility, again, we're grabbing our current pointer position and we compare that. Resize value is the difference between our current pointer position and the last pointer position from last frame. And then we take that size delta, that change in size, and we add it with positive X and a negative Y. And then we clamp it with our max size and min size, And then finally, we just simply grab that size delta and reset it. And the last final bit, we set our current pointer position. And so if we come back to Unity and we grab that resize panel and we drop it onto our resize zone and we save this, and then we go to play mode. Oh, and we have to set our maximum and minimum size. I did that in testing. So we've got our resize zone, and right now it's set to 0. What size are we now? Let's look at our panel. Our panel is about 200 by 300. So let's say our minimum size for that is going to be 100 or 150. Let's say 100 by 100. And our maximum size, 500 by 500. Big round numbers there. So now when we get onto our hotspot and drag, it'll drag down to 100 by 100 and out to, well, 500. It's bigger than our current screen that we've got right now. But we can drag that up. So that's dragging. That's dragging the panel. That's resizing the panel. That's closing and opening the panel. The only last thing that we need to make this work in all occurrences is one last script, and that is, let's create a new C# script. And that new C# script is going to be called focus panel. Because of the way the events work, when we click, let me go into play mode, and let's bring our little default image back. Come on, you can move around. When you click on the panel, it's going to pop to the front. You can kind of see that. Let me move that position one more time. Let's go back to this guy. Let's move it around. So there we go. So we click on our panel, and it will pop to the front. On the other hand, if we click on the body of the panel, because remember we only have a hotspot at the top, I'm clicking on the panel and it's not coming to the front. It'll come to the front if I click on anything that we have with our specialized scripts, with our resize or our move. But we want to be able to click on anywhere on the panel and have it pop to the front. So we're going to write another very simple script here, which is our focus panel. And focus panel is just going to be, and we need our UI and event systems as well. So let me just go ahead and copy those. And so that's our Unity Engine UI and Unity Engine event systems. And we're going to also use iPointerDown handler. Why don't I see it? Because I don't have a colon at the end, semicolon at the end. Okay. Oh, come on. We've got that all working. We've just blown your... Don't make me write it. Oh, I'll make me write it by hand. Pointer down handler. Oh dear. I have to write the thing out? No extension? Heck. So there's our focus panel with our event systems and our UI. And we write, again, private Rect transform, because we have to get Rect transform. And let's call that our panel. And then in awake, we say our panel is get component Rect transform. And then also realize that we could be saying, transform as Rect transform for this. Both work. So we grab our Rect transform and then simply public, remember that's public, void on our on pointer down. Replicating that line we've seen so many times before. Once we get our pointer event data. Our data. Still worried that I've got a problem somewhere because it's not completing. We wanted to set our panel set as last sibling. So that's simply anytime we touch that panel in any way, it's going to pop it to the front. So let's save that, come back to Unity, and now find out where I've made my mistake. Why it doesn't like that? Event systems. Let's see what I failed to copy. Yeah, it's the S. Event systems. Save that. Okay. And throw that on to our panel. And we now have focus panel on the panel, so we can save this. We can hit play. And now, whenever we touch anywhere, it'll focus it to the front. And we can duplicate this. So we can have multiple panels. We'll confused it. So let's duplicate this, not at runtime. Okay. Yeah, I confused somebody's reference by duplicating that at runtime. So now I have these two panels, and we can do fun things like change the color so we can see that they're different, and then pop them back and forth in front of each other just by touching anywhere on the screen. We can drag them around. We can resize them. We can close them. We can close or reopen the one that we've linked, but we obviously can't close and reopen the one that we have not linked. So that's panels relatively quickly in a flash. There's obviously more to do with these. We can start getting into procedural content, and we can get into scroll bars. Not going to happen today. It's going to happen in another future session. And now I know that looks a little bit complicated because we are writing stuff in the UI, and we are using some pretty intermediate stuff here by implementing interfaces and using some very long-winded code. But it works, and once you write these once or copy them off of the archive page, you have it, and you won't have to do it again. Metal Cat. Let me actually show you something. You can use lots of canvases. Let's see if I can find it. I did this over the weekend, and this is performant to a degree, but when you get to this many canvases, if you look at this, this is more than 300 world space canvases, and I'm getting reasonable performance off of this. Now it's going to be a little bit slow right now just because I've got Twitch running and a bunch of other stuff. And each one of these is a world space canvas, and with a billboard script on it, and it's not very well optimized. I would probably do something different. If I was to really put this into production, I would very at least would pool the billboarding under one script, because each one has their own update and each one is billboarding on their own. I'd have one script that billboarded all of them, or I would consider reaching out and grabbing their location and putting them in, doing them in screen space. Also the distortion, because of the camera that I'm using, you can see that you get the barrel distortion on the camera. And because there's no limit to how far I can push this, you have to get more clever than simply billboarding your canvases, because notice that they start to fail when you get into some extreme positions. So yes, you can billboard lots of things. You can billboard. I'm billboarding successfully, and when I'm not running Twitch and snagging this off the web, I'm getting perfectly fine speeds off of this. But this is 300 or so billboarding canvases, and it's probably there are probably more optimized ways of doing things. Well, Metal Cat, if that's what you're doing, then maybe you should ping me on the forum, and I can tell you what I've done. I have no problem with showing you how I did that. There was about 3 hours worth of work on Sunday. It can be done, but I think that there are better optimizations than just doing a proof of concept in a couple of hours. So thank you for coming, and you can follow us on Twitter at Unity3D, at Mike Geig, at Will Goldstone, and me at The Ant Ranch. That's Adam Buckner. If you have any suggestions, please leave them in the teaching forum under the topic or thread live training. Any suggestions, criticisms, comments, care packages, that sort of thing, leave them there. Cool. All right. Thank you very much.